This video is on single replacement reactions and the reactivity series of metals. So first thing, just want to recap really quickly, what is a single replacement reaction? Sometimes they'll also say single displacement reaction. It means the same thing. Okay, we're going to have A plus BC. So this first thing is going to be some kind of element, and it's going to be by itself. Okay, it is alone. And then the second thing is going to be a compound. So there's going to be two things together. This is always how single replacement reactions will look. Sometimes the compound and element will be in different spots, but you're always going to have one thing by itself, which is the element, and the compound. So the element is going to attack the compound. Okay, whatever this metal is going to attack the other metal. So A is going to attack B, B gets kicked out, and now B is alone, and we're going to have A is bonded to C. So B is switching with A, essentially. Okay, this is a single replacement reaction. So it is possible for the A and the C to switch, but we're only going to do A and B examples in this video. So comparing this to double replacement, how can you tell which one's which? Here, the A and the C are going to trade places, but really the difference between the two is that in a single replacement, there is going to be an element that is alone, versus in the double replacement, all of the elements are going to be paired up. Okay, so single replacement, they're alone. Double replacement, they both have pairs. Similarly, they will both switch. So in this case, the A and the C switch spots. So that's just kind of a quick comparison between those two. Today we're going to focus just on single replacement reactions. So if you haven't already, I want you to pause this video and write down this list on the sidebar. The order of the list is really important. It is the reactivity series of metals. So go ahead and pause this video, write that down, and then come back to it. So the way the reactivity series of metal works is that basically the top are very, very reactive. I like to think of them as being very, very strong. Okay, the bottom of this list are the less reactive. Okay, these are the weaker elements. They have less strength. So some rules and basically how we can use this reactivity series of metals. So when something's stronger, so when you have a stronger metal, it can attack and it will kick out a weaker metal. So when something strong attacks, that means it will work and it will perform a single replacement reaction. When we have something weaker that is attacking, well, it's not as strong, so it's going to fail and it's not going to perform a single reaction. What's going to happen is just no reaction. You will see literally nothing. So let's look at some examples of these single replacement reactions and how they work. Okay, so let's say we have calcium, Ca, and it is reacting with some aluminum oxide. Okay, so the question we're asking is, will this reaction happen? So we know it's single replacement because calcium's by itself. Whatever is alone, I like to think about it like this. He's alone, he wants a friend, he's going to attack. Okay, so the calcium is going to attack aluminum. We need to look, where are they on this reactivity series? And we'll see that calcium is higher than aluminum. So calcium is stronger, which means that it will work. Okay, this is going to be a successful attack because calcium is stronger. Okay, so the calcium and the aluminum are going to switch. Aluminum gets kicked out by himself, and then here's our resulting reaction. Okay, and these come together. You have to look at the charges to determine what comes out. So I'm just going to balance this equation really quickly. It's always good to balance our equations. All right, so next example. We will have aluminum is reacting with some copper sulfate. Okay, so aluminum's by itself. So aluminum is going to be doing the attacking. Okay, right? This is the single part of the single replacement. So aluminum attacks copper. Look at the chart. Where are they on our reactivities chart? We have aluminum and we have copper. So is aluminum stronger than copper? Yes. Yes, it is, because it's higher on the chart. That means this will be a successful attack. Copper is going to get kicked out by itself. And then aluminum is going to bond to the sulfate. I'm just going to take a second. I'm going to balance this one as well, just to get practice balancing in. Okay, so we have iron is reacting with some magnesium carbonate. Okay, so iron's by itself, and it's attacking magnesium. Remember, whatever is alone is what's doing the attacking, right? He's lonely, he wants to attack. So we have iron and magnesium. But iron is lower than magnesium on the reactivity series. This is not going to work. Okay, iron is not strong enough to beat out magnesium. Magnesium is just way too strong. Okay, so this is just no reaction. It's not going to happen. So when something lower tries to attack, it's just not going to work. All right, so why don't you guys try this example and see what you think. So we have zinc is reacting with AgNO3. So will this reaction happen? Yes or no? Take a second, think about it. Will this happen? So remember, zinc is attacking silver. Okay, so where is silver? Where is zinc? Yes, this will happen. Zinc is stronger than the silver. So yes, this will occur. All right, and one last example for you guys to think about. So if I have tin, SN, and tin is attacking some sodium sulfate, will this happen? Yes or no? Take a second, think about it. Look at the reactivity series. So tin is doing the attacking because it's what is alone. And the answer is no, there is no reaction. Tin is really low on the reactivity chart, and sodium is much higher, so sodium is stronger. This attack will not be successful.